If you look at problem number 241, it's not a pattern that comes up often. Just take note of the content for your reference. It can be referred to as depth gain compensation or DGC. The value that is adjusted here is the answer for option C. So just remember that it is adjusted in units of decibels per centimeter per megahertz. Now let's look at problem number 242 right below. This question asks you to choose the function related to the receiver. It is asking which function converts the radio frequency signal here into an electrical signal. The function that smoothly converts the incoming signal into an electrical signal like this is the demodulation function, which is option D. Or you can also remember that expressions like smoothly changing the waveform itself are related, so keep that in mind as well. Now let's look at question number 243 below. Here, you should also pay attention to the related keywords. Among the components of the ultrasound system, this question is asking which part directly transmits the pulse to the patient. The part that directly delivers it is the transducer in this case. So expressions like transmitted from the pulsar to the patient are related to this answer choice, so make sure to note that through this question. Let's look at question number 244 next. Yes, you can also take this question as a reference. This question is asking about the reason why incoming raw data signals need to be compressed. So, it needs to be converted to a small dynamic range. To explain this simply, you can think of the signals initially obtained by the equipment as this kind of raw data. These kinds of data have such a wide range that they cannot be displayed directly, which is one of their characteristics. In order to convert the signals here into an image, you need to change them to a narrower dynamic range so that they can be displayed. Therefore, the reason compression is necessary is best explained by choosing option C. In the case of the incoming signals here, they have such a wide dynamic range that they cannot be displayed, which is why compression is necessary. You can summarize it this way. Next, let's move on and look at question number 245. Since this is a basic question, let's find the answer right away. If you're asked which is not a function of the receiver, look at option D, dynamic aperture. The rest of these functions you can consider as functions of the receiver. Let's also look right away at question number 246 below. Looking at the question, it asks about the function that limits the propagation speed in the tissue, which is the speed of sound. The correct answer is PRF, which is option B. In the case of this question, there could be some controversy and it's not very important, so you don't really need to go through the solution separately. Alright, let's move on. Let's look at question number 247 below. The question says that the attenuation coefficient is set high. In this case, the question is asking which part of the image should be adjusted. The fact that a lot of attenuation has occurred means that compensation for that part is needed. The function most closely related to this situation is compensation, which is option D. Most commonly, when the term attenuation comes up, the keyword most directly related to it is compensation. Next, let's move on and look at question 248. In a previous lecture, I explained about the duty factor. The duty factor is defined as the ratio at which the actual sound wave is emitted. In the question, it says that you want to increase the duty factor. If that's the case, if the actual sound wave increases, the duty factor here will also increase accordingly. The correct answer is to choose increase the pulse repetition frequency, which is option C. When the frequency at which pulses are repeated increases, the number of pulses also increases, and as a result, this is related to an increase in the duty factor. Now let's move on and look at question number 249. This question is related to pre-processing and post-processing. I can also emphasize that this is a pattern that is always included in the exam. Here we have write zoom and read zoom. To explain it simply, I mentioned that you read first and then write. So you read first, and post-processing, read zoom, refers to the reading process. Here, the question is asking what advantages write zoom has over read zoom in terms of magnification. The concept of pre-processing refers to the state before the video is stored, so you can think of situations where video is being generated in real time. On the other hand, post-processing refers to magnification that occurs after the video has already been stored, so it follows a somewhat different pattern from real-time processing. The main advantage lies in this aspect. In the case of live zoom, since magnification occurs during inspection, the spatial resolution here does not have a significant impact. However, if you enlarge a photo after it has already been taken, the pixel quality decreases accordingly. Therefore, with red zoom, since you are enlarging an image that has already been stored, there is the disadvantage of reduced spatial resolution. This is the first comparison between the two here. Next, the most frequently discussed point is actually what this question is asking about. So in terms of spatial resolution, live zoom is superior. Just make sure to check this point carefully. Now let's move on and look at question number 250. This question is asking how the depth of a reflector is determined in a pulse wave ultrasound device. Yes, the basic concept of a pulse device is that a pulse is sent out and then returns, and that's how the image is obtained. To determine the depth here, you can measure the depth of the reflector by checking the time it takes for the pulse to travel to the reflector and back. The correct answer is D. You can think of it as measuring the depth by timing how long it takes for the pulse to go out and return.